Today we're going to learn about fronts. A front is where air masses meet but do not mix because, well, their temperatures are different. And because the temperatures are different, so are their densities. And this is how a front is formed. There are 4 types of fronts. There's a cold front, a warm front, an occluded front, and a stationary front. You will need to know each as well as the lines that form the fronts. Notice the picture to your right. These pictures, these lines, represent each front on a map. You will need to know each. Let's look at a cold front. A cold front is a cold air mass that is replacing a warmer air mass. Shown on a weather map by a blue line with triangles pointing towards the direction the air is moving. Because the triangles on this line are pointing to the right, the cold air is moving towards the right, displacing the warm air. And because cold air is more dense than warm air, as the cold air mass meets the warm air mass, it moves underneath it, pushing the warm air up and out of the way. When these 2 types of air masses meet, they tend to form strong weather systems. You'll see a lot of thunderstorms, a lot of rain clouds will form with a cold front. So, rapidly moving cold air mass runs into a slowly moving warm air mass. The cold air will move quickly down because, well, it's heavier. And warm air moves slowly because, well, it's less dense and it takes time to rise. The denser cold air slides under the lighter warm air, pushing it upward. The rising air cools and condenses, forming clouds. This causes heavy rain or snow to fall. If the warm air mass contains only a little water vapor, you may only have some cloudy skies. Cold fronts move quickly and can cause abrupt weather changes, including violent thunderstorms. When a cold mass quickly hits a warm air mass, you will hear thunder. That's the result of them colliding. A cold front passes through after a cold front passes through, cool, dry air moves in. Clear skies and cooler temperatures often follow, and the air is pretty dry. A warm front. Warm air mass collides with a slowly moving colder air mass. Shown on a weather map by a red line with half circles pointing the direction the warm air is moving. Okay, so once again, the warm air will be pushed up, but it's strangely moving faster than the cold air mass, probably because the cold air mass has been stalled due to another air front on the other side of it. So warm front. A moving warm air mass collides with a slowly moving cold air mass. The warm air moves over the denser cold air. If the warm air is humid, meaning it has a lot of water and moisture in it, showers and light rainfall along the front where the warm and cold air meet can occur. If the warm air is dry, you might just have a few scattered clouds. Okay, so a warm front. The zone where warm air is replacing colder air. Air gets more humid after a warm front moves through. These are the lines you will need to be able to recognize with the warm front. Notice the temperatures on the map. Let's look to the map on the right. Notice how the temperatures at the top of the picture are lower than the temperatures below the picture. That's because the warm front is moving in. You can see where the warm air mass is. After the warm air mass overtakes some of those other states, their temperatures will rise as well. Because warm fronts move more slowly than cold fronts, the weather may be rainy or foggy for several days. After the warm front passes, weather is likely to be warm and humid. In winter, we love warm fronts because they tend to bring us snow. Yay, snow day! So let's compare these. Cold fronts move faster than warm fronts, most of the time. The weather activity in cold fronts is often violent and happens directly at the front. This is where we get our thunderstorms from. Cold fronts have sudden, gusty winds high in the air, creating turbulence. The weather activity in a warm front generally happens before the front passes. In a warm front, the cloud formation is very low, often creating situations of poor visibility. This is where we get a lot of that fog. So now let's talk about occluded fronts. A cold front is represented by a blue line with triangles. A warm front is represented by a red line with circles, but an occluded front is represented by a purple line with both triangles and circles. An occluded front occurs when a warm front is trapped by two cold fronts. These two cold fronts lift up that warm front. Look at the weather map shown by a purple line alternating with the triangles and semicircles pointing in the direction of the front. Just because it's pointed in a certain direction doesn't necessarily mean it's moving very quickly. They will move. They're not stationary, they're not staying in the same place, but they'll probably move a bit slower than the other fronts will. Thanks to this, we'll get some major storms. The denser cooled air masses move underneath the less dense warm air and push it upward. Basically, this becomes a sandwich. Okay, the temperature near the ground becomes colder, but the temperature up high in the atmosphere is warmer. The warm air mass is cut off or occluded from the ground. As the warm air cools and its water vapor condenses, the weather may turn cloudy and rainy or snowy. So now let's look. Occluded front is formed when a cold front overtakes a warm front. This is basically what it looks like on a map. Here we go. This occurrence usually results in storms over a large area. In the United States, the colder air usually lies to the west. Okay, the last front we are going to talk about is a stationary front. And stationary is exactly what it does. It does not move, okay? Or it's moving incredibly slow, which is why you will have triangles and circles on both sides of the line. Shown on a weather map with alternating red semicircles and pointing away from the warm air and blue triangles pointing away from the cold air. Sometimes cold and warm air masses meet, but neither has enough force to move the other, so they're basically in a standoff. No one is able to move. Where the warm and cool air meet, water vapor in the air condenses into rain, snow, fog, or clouds. It may stall over an area and bring many days of clouds and precipitation. Many days of clouds and precipitation. So let's review. A stationary front is where either a cold or warm front stops moving. The warm air mass will be behind the red semicircles. The cold air mass will be behind the blue triangles. When the front starts moving again, it will return to either being a cold or a warm front. Let's practice reading a weather map. Can you identify the cold fronts on this weather map? There's one off to the left, one in the center, and one to the lower right. Can you identify the warm front? There is one warm front between, actually along the lines of the United States and Canada. Can you find the stationary front? Very good. This is why there's so much rain down near the coast at that time. The air's not moving. They're kind of stuck. Can you find the occluded front? There it is, hidden at the top left of your screen. A little hard to identify, but there it is in purple. Now, let's see if you can truly read this weather map. You are planning to travel to Alabama in 2 days. The high temperature there for today is 68 degrees Fahrenheit. And yeah, there's a little star on Alabama to kind of help you out. Use the map to help you predict whether the temperature in Alabama will increase, decrease, or stay the same. Explain why you think so. Take a moment to notice the cold air mass, the cold front moving towards Alabama. What does this mean for Alabama? There is a cold front approaching. The temperatures will probably be colder once the cold front has overtaken the city and the state. Of course, meteorologists, which are people who forecast weather, use much more data than fronts and air masses to help them to forecast the weather more accurately. But any forecast is just a prediction of what might happen. Even with the best data, weather forecasts can be wrong.